Good morning, my dear students. My name is Paulaj Vishal, Assistant Professor, JIS College of Engineering, Department of Mechanical Engineering. And that today discuss the fault tree analysis. This is the under the subject of quality and reliability engineering, and this is my lecture number 32. And the fault tree analysis, basically fault tree analysis. That means the FTA is to top down the deductive failures analysis, in which an understand state of a system is analyzed using Boolean logics to combine a series of lower level events is considered. That like this analysis method is mainly used in safety engineering and reliability engineering to understand how systems can fail, to identify the best ways to reduce risk, and to determine or get a feeling for the event rate of satisfy or the rate of safety accidents or a particular systems level. That means your the functional failures is considered according to your the fault tree analysis. If to come here, the different type of accidents is come in your the industry, that like your the required for safety for each and every people who is work in your industry. Then you have to consider according to your the risks, and also determine to the gate of feelings is considered. And FTA is used in the aerospace, nuclear power, chemical and process, and also the pharmaceutical, petrochemicals and other high hazard industries also will be used as like your the fault tree analysis. That is the you have to consider the different type is fault is going up in the industry, and also due to the different type of cost and your the process the manufacturing units during to this the different accidents will be occurred during to this the systems. Then you have to always recovery from this the different type of fault from you have to consider. That means your the fault tree analysis, and also the is comes basically the high hazard industries, high hazard environments. You have to recovery your recovery your the safety precautions are like your the accidental conditions will be recovered during your the fault tree analysis. Now you can see here that this will be the simple diagram is given, like your the fault tree analysis is here. The example process water systems will be here, that like your the process water systems will be considered, that like the this type of fault tree analysis will be come out during to this the system. Like the first is considered according to this the harm curing temperature low will be considered. That like is the you have to consider that your the curing temperature is the very low temperature will be comes out, and then you have to record for the different harming conditions also will be here. And also you have to given a gate, that like your the OR gates will be given, that like a symbol. And OR you have to consider the during to this the another one the temperature Dale defective will be considered, that like your the first thing is considered the curing temperature is low, and this is the on consideration. And another is the or the temperature Dale the defectives will be comes here. Another thing is considers the AND gate is given, that like the AND gate OR gate will be considered according to or discuss or the fault tree analysis. The production or the procedures not available at workstations will be considered, and the procedure is the not available at this workstation. Another thing is here that like is hazards will be come during the, because your industry is not will be considered according to your the available procedures is here. And the operator untrained, and the few cases you can consider, just like the two cases is here. That is the one is the your process is the not is the available in your industry, and another things will be considered. Then your process is available, but your process is not properly handled your people in the employee, because this will be not is the proper skilled labor is available during to your the company. That's your operated water under this is the this hazardness will be come during to this. And another things will be considered the the calibrations not performance, that like your the another hazardous conditions will be here, that like your the equipment is not fully calibrated, that like your performance is not will be the calibrated performance. And this is the considers your equipment is given this output value, but this value is not will be properly maintained according to this your the measuring units, then this will be differ from this, just like your the not the calibrations are done on this equipments. Then another things will be here, the in connectly set is considered, and also the sensor fault will become like the your sensor fault is the much more the equipment fault is the very difficult, because the sensor will be sensed that like your the notice the appropriate value will be sensed in this sensor, and the sensor is the sense the less or more the temperature, the more concentration, then this will be the difficulty this arise, and this is considered according to what the hazardous conditions. And then you have to given the OR gates, the temperature dial defectives, that means that these considerations will be coming during your the OR gates, and this type of fault will be discussions the according to what the fault tree analysis here. And the fault tree analysis is also used in software engineering for debugging purpose, and is closely related to cause eliminations technique used to detect bugs, is considered that during period the fault tree analysis. And another things in aerospace, the more general term system failure condition is used for the undesired states. The top event of the fault tree is required. That's like your the aerospace industry. That's like your the aeroplanes. You have to this is the more general term. That like the system of failures will be coming out during to their conditions in used for the undesired states is considered the top event will be top event is comes here of the fault tree is you can see here the system failure conditions is use the undesired states. And another things that those conditions are classified by the severity of their effects is considered. And another things, the most severe conditions require the most extensive fault tree analysis is required during your the aerospace industry. And another things we can see here, the this system's failure conditions and their classifications are often previously determined in the functional hazardous analysis is required, because the just like your figures you can see that just like your the hazardous conditions, and during to the hazardous conditions will be a different type is hazard is come in your the in your industry, that like your the you have to require for this different classifications the mass more essential, the which type of hazards you can be overcome, the which type of hazard is not will be overcome on this system. Then this you don't know the which type of hazard is comes in your the fault trees, then this will be difficulties for the different hazardous functions also will be required to analysis properly. And then you have to few hazardous cases can be recovery, and also few cannot be recovery, and also the your few cases you can see just like your the equipment problems, and a few cases not will be the manpower problems will be here. And used in of fault tree analysis, the basically fault tree analysis can be used to the understand the logic leading to the top event, and the undesired state is considered. You have to record what is the logics you will consider according to the top, that likes the you can see the previous slides. Then brings and the your the that likes this one, the curing temperature is the low, or and you have to consider the that means your the temperature dial detective. Then similarly the you can see here the your fault area analysis can be used to understand the logic leadings. And another thing is the show compliance with the input system safety reliability requirements, that means the you have to compliance the different cases your the input data is given properly, that you are the with safely, and also the each and every industry first things is considered according to the personal safety, because you cannot be safe, then you cannot be work properly. That means your whole systems will be collapsed during toward the not satisfactory for your the safety jobs. That means the show compliance with the input system safety reliability requirements is considered. And another things, the priorities the contributors, that means you are the leading to the top event, and the creating the critical equipments, that means you are the critical equipments, the parts events list for the different importance measures also will be required during toward the use of the poultry analysis. That means you have to different importance measurements also will be required, that like your the critical equipments, the parts, and also the different type of events will be considered, that like the not also only depend on the equipment. This is a few cases will be considered your the skilled labor is not available in the industry, then this will be also used for your the poultry analysis will be here. The monitors and control the safety performance of the complex system, that is the in particular aircraft safe to fly when the fuel valve X malfunctions, also malfunctions. Basically this is the difficulties, the monitor and control the safety performance the complex systems. You can hear the few cases we can see that your aircraft is the safe to fly, but your the safety valve will be or fuel valve, this is the not will be fully safe, that like your the malfunction is considered. And a few cases when we have to starting out the cycle and also your motorbike, then you can see that this will be sparking is the difficulties counts, but this sparking will be there few times will be recurred during to the sparking condition. And suppose you have to the firing is not properly done during to this the your bikes, when you have to record for this the few times will be expend during to the firing conditions, but this will be fault will be comes during to this here. And for this the similar type of fault will be considered according to the aircraft concentrations or the monitoring and control. And another things, how for how long is it allowed to fly with the valve when malfunctions is considered. Then because this will be considered the flying will be the in the air, that then this will be record for the how many times will be allowed to this the fly with the valve many malfunctions also will be considered. And another things, the minimize and optimize resources will be required. That means the which is the your resources, the what is the minimum resources used, and also now we can given the service according to your the requirements, and this will be the minimum resource. And some cases we can require the optimize your resources. That means that you have to optimizations your resources, and again you have to starting your the job and assist in designing a system, that like the poultry analysis can be used as a design tools, that is the help to create output. The lower level requirements also will be considered here. The function as a diagnostics tool to identify and the correct causes of the top event is here. It can help with the creation of diagnostics manuals. Process is considered according to this, that like your the function as a diagnostics tool to the identify and the correct causes of this the top events. And another things is here, that like your the history is come during to the poultry analysis, the where is the comes from the history. And basically the poultry analysis was originally developed in 1962 at Bill Laboratories by A.C. Watson under a U.S. Air Force Ballistic Systems Division. And during to this the seen your the poultry will be some come, that like your the research paper is the published and like as a handbooks during to this 1962. And applications of poultry analysis for use with fuses was explored by Picatinny Arsenal in 1960s and 1970s will be comes during the application of the poultry analysis. And another person is here. In 1976, the U.S. Army Materials Commander incorporates the poultry analysis into an engineering design handbooks on design or reliability is required during to this the 1966 1976. That like your the US army, that like is the different type of materials, as like your the build of materials is designs will be considered according to your the properly maintained, that like your the fault analysis. And another things will be comes here, the nuclear power industry. The nuclear power industry, the US nuclear regulatory commissions, the began using PRA method, including FTA. PRA method is including the legal the poultry analysis in 1975, and significantly expanded PRA research flowing in 1979 incidents. The 3 Mile Islands is considered. The 3 Mile Islands is coming in the 1979. And another the this eventually lead to the 1981 publication the NRC fault tree handbooks, that like what the NRC fault tree handbooks, and the NUREG 0492, and mandatory use of PRA under the NRC regulatory authorities will be considered. That means the this will be the mandatory use comes, that like the PRA, and under this the NRC and the regulatory authorities will be considered. In 1984, the Bhopal disaster, and the 1988 Piper Allah explosions. In 1992, the United States Department of Labor, Occupational Safety and Health Administrations published in the Federal Registers on record. That like your the during to this the Bhopal disasters will become. It is the basically the quality risk comes from the safety precaution is the important things that like your the poultry analysis. For this the this type of disasters and also the explosions will become in our country, that like your the United States Labor, Occupational Safety and Health Administration published in the Federal Registers, and that like your the OSHA, the Occupational Safety Health Administration, and also the PSM recognized the FTA as acceptable method for process hazard analysis. That means the PSA, process hazard analysis. The today poultry analysis is widely used in system safety and reliability engineering, and in all major fields of engineering is required your the poultry analysis. This is the history of your the poultry analysis is introduced in our different type of industry, that like your the production industry, that like our the hazardous environment industry, pharmaceutical, your chemicals industries, and all things will be comes in the poultry analysis will be. This is the history of this. And the poultry analysis methodology. The poultry analysis methodology is described in several industry and government standards, including NRC, NUREG, that likes your the 0492 for the nuclear power industry. For the nuclear power industry and aerospace oriented divisions, to NUREG 0492 for use by NASA, NASA, SAE, ARP 4C761 for civil aerospace, and any sufficiently complex system is subjected to failures as a result of one or more subsystems. The failing, the likelihood of failures, the however, can often be reduced through improved system design is considered. The poultry analysis maps the relationship between the fault subsystems and redundant safety design elements by creating a logic diagram of the overall system is comes during toward the poultry analysis methodology. And that this methodology is used under undesired outcome is taken as the root, that is the your cause the top event of a tree of the logic is comes to the top events. For instantaneous the undesired outcomes of metal stamping press operations is human appendage being stamped is here. Basically, during the metal stamping conditions and also your the build up materials, that like is used to your the different appendage is here, and you can consider the working backwards from this top event. We might determine there are two ways this called happened. This could happen during to the normal operations or the during the maintenance operations. During toward the normal operations, you have to consider the there is the less hazardous environment will be created on this, the normal operation. And few cases that like your the maintenance jobs, this is the high hazardous environment will be created during your the maintenance jobs. And also during your the maintenance operation, you have to require for your the poultry is the essentially. And another things, this condition is a logical, that means the or logical or gates, that means the considering the branch of occurring during the normal operations. Perhaps we determine there are two ways this could happen. Two ways this could happen: the press cycle and the harms. The operator or the press cycles and harms another persons will be considered according to this. This is another logical or another logical or we can make a design improvements by requiring the operators to press two buttons, two cycles the message. This is a safety features in the form of a logical AND gate will be required. That means the OR and AND logical gate is essential on this the system. The button may have an intrinsic failure rates is considered. This becomes a fault stimulus. We can analyze when fault are leveled with the actual number of our failures will becomes, that like your the probabilities. The computer programs can calculate the failure probabilities from the fault tree analysis. And basically the fault tree analysis is comes during toward the simulation consideration will be obtained. That's mean you have to first recognize the which type of analysis will be done. That means your the simulations will be occurred. You have to same type of data will be put inside of your the software. And also this is the calculation the probabilities the fault or the probabilities failures will be come on the systems. The graphic symbols is come, that like your the different type of graphic symbol is given, and that is your the poultry analysis. When you have to prepare a poultry analysis in the chamber will be considered, that like your the basic symbol used in poultry analysis are grouped at events, gates and transfer symbols. And also the minor variations may be used in the poultry analysis software. And you can see the second, you can see the previously the already given here the on diagram is given, that like you have to prepare this diagram of this the poultry analysis. That like the few graphic symbol is be considered. That is the event symbol is first described is here. The event symbol are used for primary event and the intermediate event is considered. That means your the what is your the primary event, what is your the intermediate events will be considered. That means your the primary events are not further developed on the fault tree. This will be the primary event is not further developed as a fault tree, but your the intermediate events are found at the output of a gate. That means your the output of a gate. The event symbol are shown in below. That means the first is considered is the basic symbols. The basic events will be given, that like a circle, and also this is the on a connector to this the vertical upward directions you can see, and this is called the basic event. And second one is the external event will be considered, that like you can see the five link pentagon which will be called considered here. This is the one is the this part also will be according to your the vertical upward direction is the connector. That means the external event is given here. And another things is here the undeveloped event. That means your the undeveloped events, that is the that like a rhombus will be seen here. This rhombus and also this is the connected up above to this the vertical upward direction is called the undeveloped event is considered during to this. And another will be considered according to the like ellipse is a conditioning event. That is the connected the horizontal left direction is considered, and this is the conditioning event. The which conditions will be given when you have to prepare your the poultry. That means the different type of symbols. Then this is considered the conditioning event is here. And another is here, that like the intermediate events. And a few cases we have to see that like your the intermediate events is the found, that is the required for your the output gates. And these output gates you have to always see that like your the intermediate events, You can see that a rectangle box also will be here, and also this will be connected to this up and down, that like your the vertically will be connected on this is called the intermediate event. And the primary event symbols are typically used as follows: the basic events, the failures or error in a system's components or elements. The examples: the switch stuck in open positions is considered according to your the basic event. And also the external events normally expected to occur, not of itself a fault will be coming here. And another things, the undeveloped event is considered. The undeveloped event, an event about which insufficient information is available, or which is of no consequence will comes here. And another things will be here, that means your the conditioning events. The conditioning event that restricts or affect logic gates, and the examples mode of operations in effects will becomes here, that like your the conditioning events. And another things, an intermediate events gate can be used intermediately above or primary events to provide more room to type the event description. That means your the pottery analysis is a top to bottom approach is comes here. And you can see that like your the gate symbols, and basically the different type of gate is used, that like your the OR gate, NAND gates, the OR gate, AND gates, and also priority AND gates, and also the inhabit gate will be used, that like your the gated symbols is comes here. The gate symbols is describe the relationship between input and output events, that like these symbols are derived from the Boolean logic systems is considered is here. The first is given, that like your the OR gate, and this is the first symbol is the considered the OR gate, and also this is the connected to this way. And second symbol is getting here the AND gate, and third symbol is getting here, that like your the exclusive OR gate will be considered, that is the exclusive OR gate. And fourth one is here, that like your the priority AND gate is considered. And fifth one is inhabit gate. Inhabit gate is given, and during to this inhabit gates you have to the gates work as follows. The OR gates, that means the OR gate is used, the output occurs. Output occurs if any input occurs is considered, that like your the OR gate. You have to consider the this or output occurs if any input. Suppose you have to given OR this system, then this will be found as the output, and this is called the OR gates. And AND gate is the output occurs only if all input occurs. That means your the output is fine. That is the this is the only input occurs. The input are independent, and your input is considered according to the independence input is found. And another things, the exclusive OR gate. That means your the exclusive OR gate, you can see here, that is the third symbol is the exclusive OR gate. And your exclusive OR gates, the output occurs if exactly on input occurs. That means your the output found, that means your the exactly on input occurs. And another things, the priority AND gate. That is, what is your priority AND gates? The output occurs if the input occurs in a specific sequence specified by a conditioning event is comes, like your considered is the priority AND gates. And this priority AND gates will be complete. And also the inhabit gate. The what is your inhabit gates? The output occurs if the input occurs. The output occurs if the input occurs, and under an enabling conditions, under an enabling condition specified by a conditioning event is come. Like your this is the OR gate, AND gate, exclusive OR, and the priority AND gates, and also inhabit gates. The ORs are depends according to your the condition of this. And another things will be discussed just like your the transfer symbols. The transfer symbols are used to connect the input and outputs of related faultry, such as the faultry of the symbol to the systems. NASA NSA prepared a complete documents about the faultry through the practical incidents is come here. You can see here, the one is the transfer in symbol, another is the transfer out symbol. The first symbol is considered according that like your the triangle, but this will be the upward direction is connected. This is called the transfer in, and another is the transfer out is here. This is the also a triangles you have to consider. The this is the connected is done during to this the left lines is considered, and also this is the line vertically the left direction will be considered the transfer out. This is the transfer symbols. And the fault tree analysis, many different approaches can be used to model of fault tree analysis, but the most common and the popular way can be summarized in a few steps. A single fault tree is used to analyze one and only one undesired events which may be subsequently feed into another fault tree as a basic events. The fault tree analysis involves the 5 steps that define the undesired event to study. The definitions of the undesired event can be very hard to uncover, although some of the events are very easy and obvious to observe. An engineer with a wide knowledge of the design of systems is the best person to help define a number of undesired events. Undesired events are used then to make fault tree analysis. Is fault tree analysis is limited to one's undesired event is here. The obtain understandings of the systems. Obtain an understanding of the systems once the undesired event is selected. All causes with probabilities of affecting with the desired event of 0 or more are studied and analyzed. Getting exact numbers for the probabilities leading to the event is usually impossible for the reasons for the selected event. All causes are then number and the sequence in the orders of occurrence, and then are used for the next step, which is drawing or the constructing the fault tree. The construct the fault tree will be comes here, and also the evaluating the fault tree, and this will be construct fault tree. The after selection undesired events and having the analyze the system, so that we know all the causing effects, we can now construct the fault tree. The fault tree is based on the and or and or gates, and another things is here the evaluations in this fault tree. Then we can analyze the possible improvements in the other words, stay in the risk management, and the find where the way for system improvements. The steps is and is as an introductions for the final steps will be control during toward the hazardous identification, and also the control the hazard identified. This step is very specified and differs largely from one steps system to another, but the main point will allow us be that after identifying the hazards, all possible methods are pursued to decrease the probability of occurrence is here. Thank you, students. Next class is discussed according to the different risk assessments.